Thank you, everyone, for joining me today. My name's Lucy, and today what we're going to be talking about is optimizing time-sensitive deployments by the choices that you can make within Octopus and architecting, I guess, for efficiency within large-scale rollouts. Specifically, we're going to talk about some strategies and signpost features that you can use, which will help increase your throughput. Let me start by giving you a bit of background on me. I'm a senior product manager at Octopus. I work in the deployment domain of how we actually, the back end that does all the deployment stuff. I've been here for a year and really been looking at how we scale that and how we can make sure we keep up with customers' increasing needs as they scale. And so I'm going to talk you through some aspects of that, ensuring that you can, if you do have time constraints around deployment windows and things like that, that you'll set up as best you can to actually make that a pretty comfortable process. So let's start off with what is typically industry best practice. I've stolen this particular image from SAFe, one of many, many frameworks that you can look at. But generally, industry best practice is this idea of continuous deployment. And it's sort of held up as the gold standard that everyone should be working towards or aiming for. That's all well and good. But what happens if you can't do that? And it's just not a realistic goal or ambition. And there are really good business reasons for this. And some of those business reasons are as a result of technical constraints. But if you've got an older application or anything where you can't do zero downtime deployments, maybe you don't have another machine to fail over. Maybe you're doing isolated machines. Maybe you have contractually agreed deployment windows. Maybe you need to do out of hours stuff. And maybe there are just a lot of prod machines that need to be updated in a very, very short space of time. Otherwise, bad things happen. So what we want to look at is kind of what we're talking about. What we want to talk about is how we do lots of machines within a short period of time and what that might look like. There are some common characteristics here just in terms of this particular scenarios that we're talking about. We're talking about prod deployments typically. We're not doing large scale of machines in development environments and things like that. It's out there. It's got people using it. If we're going to cause an outage, that's going to disrupt our users. And so that needs to be managed. We usually need to finish all machines within a certain period of time. And in this case, what we're talking about is not just small number of machines, but something where we need to actively manage the throughput to achieve the goals that we want to achieve. We may require enough time to roll back within that deployment window. And because we're often not doing this particularly frequently, we might have quite a large change set that needs to go out the door. So we might have a month's worth of development that we want to release at any point in time. And there are obviously, sometimes there are contractual obligations around this. So the kind of scenarios that we see in our customers are things like rolling out to medical devices in hospitals, rolling out to point of sale machines overnight in retail businesses, rolling out to factories and manufacturing equipment. Various things like this are where you're not able to do a zero downtime deployment. You need to manage it when the tool isn't being used, and you've got a lot of things that you need to update all in a specific set of times, and there's quite a lot of coordination around that. And so this is where throughput becomes the interesting challenge, and this is really where we're going to spend the time today. So I've mentioned throughput a couple of times. What is throughput? Throughput's really I guess, how many deployments you can do within any given time. Every customer will have different requirements about this. We hear people having 30-minute deployment windows. We hear of people having 8-hour deployment windows. We hear of people doing it over super fast networks, and other people going, well, actually, I've got to deploy to rural communities over sort of home network environments. And broadband can be a strongly influencing factor there. I guess when we talk about how to increase throughput, though, other than those large system-wide constraints or environmental constraints you've got, the three things that we want to talk about are increased parallelization, shortening each deployment, and improving system performance. And that's where we're going to spend our time today. And the majority of it, we're actually going to spend talking about increasing parallelization, because it's a tricky topic. It's something that people make choices about often before they understand the implications of it. And so I just want to give people a bit of a model to think about parallelization with, so that they know where they might be getting into issues before they hit those issues. To start with, let's get everyone on the same page around when we talk about a deployment. What are we actually talking about here? In very, very simple terms, a deployment, you typically have an application, you have some sort of deployment process, and it goes out to machines. There is some configuration there are some constraints around that, and the deployment process is typically made up of steps. And we can break those steps up into the pre-flight checks, which are the things that you need to do before you actually start doing the actual deployment or the activities that may cause an outage. And then you do the thing, and then you have to validate that it's actually worked. And typically, we find that most deployment processes have some aspect of all of those. They definitely have the middle one. And usually as they get more mature, they have more around the front and the back of those. So let's talk, now that we've got that sort of understanding, things we care most about in optimizing throughput are concurrency, or that parallelization that I mentioned. And there are kind of the two levels that you can do that at. One is the task level, and the second is the step level. And we'll pick up those separately. We'll spend a bit of time there. We'll then talk about some of those pre-flight checks. This is really how you shorten your deployment duration by doing what you can ahead of where you're actually needing to do the deployment. And then there's configurations, some tweaks that will help you along the way with system performance and various aspects like that. And we can talk about failure mode and just a few quick tips and tricks to help you along the way. Right, let's focus on concurrency. I talked about two different modes of concurrency. The first is really modeling choices. I'm going to talk about this as task level concurrency, because if you're familiar with Octopus Deploy, you will be usually familiar with the task list and the task queue, and this is where you see your deployments happening. And the level of concurrency you can achieve at this level is generally determined by some of those modeling choices, which are how you manage the relationship between your application and your machines and your deployment processes. The reason I think this is really important to understand early on is because most of the time, well, what we're talking about here really is projects within, or is the construct within Octopus Deploy. And most people, when they're thinking about projects, and they're thinking about how they want to split up projects, they're thinking about teams, user access, Git repos or source control, and trying to get the structure right there for how they set up their projects. But it will have an impact on the level of task concurrency you can achieve depending on how you do it. And what I mean by this is really thinking about whether you have one application to one project, whether you split an application into components across different projects, or whether you have multiple applications within one project or something else. You know, there are combinations of those that you could apply. So this is one of those decisions that people will make for a lot of reasons. There are all of those are really good things to consider. They're just a bit beyond the scope of this particular talk. So I'm going to focus on the performance aspect so that you can just understand, if you're getting set up, how you're going to, what the implications are. Because the thing that we find with our customers is when they do get into kind of those moments of regret, it's often at this level and they're like, we got it wrong, but now we're in the process for doing that, and that's how we've rolled out across the organization. And it's quite difficult to start changing at that point in time. So getting this right is something that's quite important. You can change a lot for a lot of the other stuff at a later point in time, but really do spend a bit of time here and just working through, if you know you've got some time pressured deployments, this is kind of the important stuff to get right, otherwise to avoid rework. The next bit is machines. You have a number of machines that you need to go out to. How do you want to manage those? Are you using targets and target tags, or are you using tenants? What we often see with tenants is that our customers use tenants to segment their customers or their locations, maybe their stores or particular cloud regions. But tenants will also impact the level of concurrency that you can achieve between your various deployment tasks. So it's worth having a think about that. I'm going to step through some examples of how this impacts those tasks, and so what can happen concurrently and what it can be limited by. It is worth saying, we'll talk about task caps in a bit, but assume what you've got when you talk about task concurrency is that that is something that's very easy to increase. So one project, one deployment process to one machine would be one task. A second project deploying to a second machine would be a separate task. You could run these in parallel. If we have one project that is deploying to two targets, two machines, that is one task. We don't necessarily separate out the machines at this level. It would be one task, and the deployment would need to complete on both of those machines before that task completed, and you could start another task. If, however, you use tenants and those machines are assigned to tenants, that will actually split out two tasks. So you could have exactly the same process going to the same number of machines, and in one situation it would be one task, but with the inclusion of tenants, you could make that two tasks. That gives you just a bit of optionality about which direction you want to go in for this. This, just to show you here, is the UI where I think it's in the project settings where you can allow deployments to use tenants, although you have to map the project to the tenants as well as configuring the tenants themselves. But yeah, that's a really good feature to explore if you haven't. Quite a lot of our customers do use it, but there are still some who are looking at it going, don't know whether that's appropriate. This is really where it becomes super useful in terms of deployment performance. Now, if we combine those two scenarios, we have 4 machines that we want to deploy to, and we have 2 in each tenant, that would still be 2 tasks. In terms of, I think something that I didn't mention earlier is when we deploy, if we have a deployment process targeting multiple machines, it will try and do things to all of those machines at the same time, which works for a small number of machines. However, as you get to a larger number of machines, you may want to think about that slightly differently, and we'll talk about that in a little bit. Where you have a scenario, we get into this is getting into the interesting stuff, actually. This is where it sort of becomes fun and a little bit more challenging. If you were to have 2 tenants running on one machine, you would have 2 tasks here. And you can control that at the machine level with the concurrency tag about how many tenants you want to run or execute on that particular machine at any point in time. There are reasons why you may want to increase or decrease that. As a default, we will execute 1 task at a time per tenant on that machine, and then the other tenant will wait, I think, for that to be done. But there are times when you might want them to work in parallel. So there's some stuff. I'm not going to go into huge levels of detail on that. We have some good documentation around it, but just know that there is a tag there that can help you control that, what is actually happening on that machine between tenants. The other thing that you'll need to do, and we'll talk about this in a bit more detail, is the bypass deployment mutex. Octopus typically only runs one process on a machine at any point in time. And the reason for this is we behave defensively around file systems. We don't know what's happening in your deployment process. So we have to assume that if you try and run same processes, it might be using the same, it might be trying to access the same part of the file system, and we want to avoid locks. So it is set to execute 1 process at a time per machine. And if you want to get increased concurrency on that machine, because you know that your deployment process is safe, there is a mutex bypass tag that you can use. Another way of increasing task concurrency, if you want to, is to use the deploy release step. This is where you trigger another project to deploy as part of your first task or first deployment process. This spins off what is effectively a child task. And so this will complete. The child task should complete before the deployment process continues on. There are some really good reasons for using this. There are a couple of caveats though. If you end up doing this in a combination with tenants and you have multiple levels of deploy a release step, you can generate an awful lot of tasks very quickly. And then depending on your task cap, you might struggle to get through all of those. So there is a point where you can end up with too much parallelization. And so we would only really recommend 1 level of use of the deploy a release set, not to chain those orchestration levels to or too many levels. If in doubt, please reach out to us and ask whether we think something is going to be problematic before you do it, because it's quite difficult to unpick once you've got there. So just going to recap some of that. Individual tasks can run in parallel, or will run in parallel where they can. This is limited by the task cap. The number of tasks will be influenced by that relationship, primarily between projects and how you're managing your machines. And the deploy release step can be used to trigger different project release processes and ensure that there is a relationship between that child project and that parent, and that they can complete in the right order. What we didn't spend a huge amount of time talking about was, which I will just say, is talk specifically about the task cap. Depending on what license you're on, you may start off with a task cap of 5. We go all the way up to a task cap of 160. We have some really exciting stuff coming down the pipeline where we're going to be able to offer a much higher task cap than that. So if you're doing really big deployments, we should be able to handle, hundreds, possibly thousands of concurrent deployments, which will ease quite a bit of that time pressure for people. So That's the task level concurrency. I wonder how many times I can actually say concurrency in a presentation. I'll have to count at the end. Now let's talk about the concurrency that you could get within a deployment process itself. The level of concurrency you have in a deployment process itself is likely to influence the length of time that particular deployment process takes to complete. And if you go back to the throughput sort of definition we were talking about, it was the number of parallel tasks and the length of each task. And so this is about how we kind of can think about the length of, one of the ways we can think about the length of each task. We looked at this model before: one project, 2 machines, 1 deployment process, that's 1 single task. However, what we talked about was it going out to all the machines at the same time, whereas there's this thing called rolling deployments. You should become familiar with rolling deployments, which is where you can set a window size to say, this is how many machines I would like to be dealt with at the same time. We typically think a window size of 10 would be a great place to start, and then from there you can dial it up or down depending on what you see happening. And that just means that we can go and tackle a certain number of machines at any point in time. We touched on this a little bit beforehand, which was the deployment mutex, which is where if you have multiple processes targeting a single machine, it will only execute one of those deployment processes at a time on that machine, or at least one of those steps, unless you say, actually, we know we've set our deployment processes up so that everything is uniquely identified and won't lock anything up, and therefore in this situation we can run more things. This will also depend on how much resource is available on that machine. Bear that in mind. Octopus assumes that it can kind of have access to everything and do everything, and it has full usage of that device's resources. So bear that in mind if there are other things happening on that device at the same time. Now, we can also do steps in parallel. This is a general configuration option on all steps. You can say run in parallel with the previous step. Again, in this situation, if you wanted those parallel steps to target the same machine, you need that mutex bypass to ensure that happens. However, if you're targeting different machines, that's okay to go ahead and do that. And that will allow you to handle multiple steps at the same time. So just to kind of give you, sort of signal you towards the finer grained controls we have of these things, if you're going to set up, we've talked quite a bit about the bypass mutex, that's really at the machine level. We have a couple of other tags around acquire max parallelism, which is about acquiring packages, and action max parallelism, which is how many steps do you want to, how many times do you want, or how many steps do you want to try and action at the same time. Again, we default to 10. You can increase that or decrease that. Be aware of the implications that increasing that will have on that machine's resources. That's really why we can't give any strong recommendations in this space. It's sort of up to you, depending on the hardware you have, and to figure this stuff out. But these are things that you can play around with, and that task concurrency tag becomes really useful around both environments and tenants when you're running them on the same machine and you're reusing. So you might, people will typically think about this a little bit more in terms of, I guess, some of those lower environments where there might be a lot of reuse on the same piece of hardware. But we're not talking about those today. We're talking about prod deployments today, and lots of machines, not lots and lots of stuff happening on the same machine. So that's a fairly quick overview of your options with regards to concurrency. What I want to talk to you about now is pre-flight activities. What can you do, when we talk about deployment processes and things being time constrained? Let's make sure that we only need to do the things that we need to do within that time constrained window. If we can do stuff in advance, let's do stuff in advance. Let's alleviate as much of that pressure as possible. This is one of the big kind of the best techniques for doing this. In general, whether you're doing pre-flight checks or whether you're having a pause point in here or not, if you can optimize your deployment process, fewer steps is generally better. Fewer and smaller variables is generally better. And also, don't forget to skip steps that are not required for prod environments. We often have, if you use life cycles, it makes it quite easy to just drop out certain environments, or to target things to particular steps, or steps to environments. Sorry, got that a bit tangled. When I talk about sort of optimizing this, I guess I'll give you some sort of guidance in terms of the number of steps. It doesn't have to be none, or a very low number. 20 steps would be quite normal. If you're getting up over 50 towards 100 or something like that, you might want to think about whether you can reduce that number of steps. We do have people go over 100 steps, but these typically take a long time, and it's just a lot more resource intensive of having to pass things back and forth between various steps within the deployment process. Okay, so that's general advice on deployment processes. What we've talked about is, I guess, those pre-flight checks and how we get between them and actually doing the main part of the deployment. And essentially what you have is you have one deployment process and you have a step for manual intervention in there. So you can pause until until the clock starts ticking, really. And that becomes the point where you want to be able to do the absolute bare minimum of what you can get away with within that period of time, so you can do it as quickly as possible. When it comes to pre-flight checks, do what you can on workers so that they're ready to go. You really want your workers, where you're using them, whether they're dynamic or self-host, you want them to be warmed up, ready to go. If they need to acquire packages, acquire those packages. On the topic of packages, do what you can to get those, moving packages around is one of the, often one of the bottlenecks. Do what you can to get them as close to the machine as possible. If you can load, or if you can move packages to the device before a deployment window starts, I highly recommend that you do that. So, if you're talking about how, trying to fine tune it so any outages are during a particular, outages occur during a maintenance window, you can do some work in advance of that to just get ready. The other thing to note here, we have had a little bit of feedback about this and are thinking about it, but in the meantime, what it is worth noting is that Calamari, which is part of Octopus Deploy, and if you're using Octopus Cloud, it needs to stay in sync with Octopus Cloud. One of the great things about Octopus Cloud is you get new features all the time. Every now and then, one of those features requires an update to Calamari, and Calamari will automatically update itself. What you don't want to do is to have Calamari update during one of these critical time periods. And so if you can do something ahead of time, or in the hour before your deployment window starts, it's a good thing to do, just to prompt that little update so it's not happening during your window. Then we get to actually do the fun deployment stuff. And this is where it's like, consider what you can do in parallel. We've talked about this. What can you accelerate with workers? How much stuff can you get done in advance or outside of the actual work that you need to do on the devices? It sort of goes without saying, of reduce the package size where possible. This does ladder back up to how you want to think about your projects and whether you can split out various different components for packages, but also consider your failure mode. And I'll talk about that just in a moment, because we've got a couple of configuration tweaks that you might want to make there. Jumping back into the package size piece, obviously larger packages are slower to transfer. They require more bandwidth, and a bigger package will take longer than a smaller package. They also take time to unpack, and they influence the size of the file system usage, and it can mean subsequent steps around scanning things and doing things take a little longer. So it's just, again, it's one of those things that's worth considering. Just have a think. You'll know your situation better than we will. So we can't give you any hard and fast advice, but just want you to understand that what the implications of package size are, so you can think about it in advance. So we've talked about concurrency, we've talked about pre-flight activities. Final piece is just kind of some configuration. This is really just some nudges in particular direction. I think I mentioned that the Octopus Cloud Task Cap goes up to 160, and hopefully fairly soon that will start to go up even higher than that. If at any point in time you do want to increase yours, is one of the easiest ways to improve throughput. Reach out to support or sales, and we'll be able to help you with that. In terms of your log files, larger log files do put the system under more pressure, because each and every step there's more work getting done. We target 20 meg, or we suggest you target that if you can, of just trying to capture things around progress and failures, and then you can publish the rest as an artifact. Similar vein, use retention policies to ensure that you're not storing too much feed information or build information within Octopus Deploy itself. If you can get more of that outside of the system, we try and make the system as performant as possible, but if you're storing years and years and years worth of data in there, things will get slower. Or you will need to buy bigger hardware, or upgrade your cloud instance. So, just think about things there. The final thing I want to talk about is really around failure modes. Fail fast if you can. You don't want to be waiting up all the time, or get to the end and find out that something failed. See if you can fail as quickly as possible, and then see if you can fail in ways that are easy to resume or continue. We have a feature that supports this, which is guided failure mode, where instead of failing a deployment, it puts a pause point in so that you can rectify whatever the cause may be. Perhaps a machine runs out of resource and you need to reboot it or something like that. You can use guided failure mode to continue on the deployment once you've gone and fixed the issue. And the other aspect around this is we have some recently introduced retries features around different steps and around network connections. Please do look at those and see what you can retry, and think about the idempotence of your deployment process. How easy is it to get the same result if you retry it? The more you can retry, if there is something that goes wrong, the more likely you are to get to a successful deployment. That is pretty much all I wanted to cover in terms of thinking about how you can optimize your throughput, and the features that we have that will support that. And I hope that's been useful and given you a bit of a whirlwind tour. I know there was quite a lot there, and it's not necessarily the most enthralling topic. However, what it should do is give you a mental model of the features that you have, and when you're looking at choices, just to be able to go, this might have an impact on our performance. We know we're going to have challenges around this. Let's make sure we factored this in the right way. And I really hope that it has provided some help in that regard if it's a topic you're interested in. If you have any questions, if you have any feedback, or you are experiencing these particular challenges, I would love to hear from you. It's something that I do spend quite a bit of time thinking about, and really trying to understand how we can help you ship what you need to ship within the time that you need to ship it. And thank you if you've made it this far, thank you very, very much for your time. I hope it was worth your efforts.